This is the screencast for section 6.3, example 2. We're going to eliminate the parameter. So first of all, eliminating a parameter is obtaining a rectangular equation in x and y that represents the curve. So you're eliminating the parameter t. So x depends on t, y depends on t. Basically, now we're trying to create a function y that depends on x as a function of x. Well, since we have y as an expression of t, we're going to take we're going to take the x expression, solve for t, and then substitute that in. So instead of x equals 1 minus 2t, I'm going to subtract 1, divide both sides by negative 2, and then I like to write it as negative 1/2 x and then plus 1/2 equals t. Now I'll take that expression and substitute it in. Y equals 2 minus negative 1/2 x plus 1/2. Basically, I'm getting what looks to be a line. Positive 1/2 x, and then that would be 2 minus 1/2, so plus 3/2. So should be a linear graph, slope 1/2, and y-intercept or initial value 3/2. So I've already graphed this on my calculator in parametric mode and also rectangular mode, or function mode as your calculator calls it, so that you can see the comparison of the two. So as you can see here in parametric mode, I graphed x and y independently. I used a T-min and T-max of 10. That was just a guess because my T-min is negative infinity and my T-max is infinity. I could have done negative 100 to 100. It wouldn't matter. I just wanted it to stretch across the graph, the window I was using. In a standard window it was. And you can see that's a linear graph in parametric mode, and it is the same exact linear graph in rectangular mode, also with a standard window. The now try problem number 11. Same concept as the example 2. We're going to eliminate the parameter, so eliminate the t, and identify the graph of the parametric curve. So you're supposed to assume, I don't know what this graph is going to look like, so I'm going to take my x expression, my horizontal change expression, solve for t, substitute that in. Wow, that was super easy. And that's going to be a linear graph, slope 1, and initial value negative 1. And of course, you are encouraged to graph that just to check.